Okay, so this is a video of problem 72 through 93 in the worksheet that you've been given. And let's just have at it. I came in here last night and put the problems on the wall, and then for some reason I wanted to show you something else here. So that'll be a different problem, but very similar to what's on your worksheet. All right, so last few tests, I don't know, last half dozen tests, and giving you an opportunity to show your conversion skills, which are based on subtraction and operational division. Obviously, if we're subtracting 5, then 5 is a critical number. And if we plug it in, 0 times anything is 0, we get a 1. Okay. It's also nice if you knew that 625 was 5 to the 4th. It's certainly been used quite often this semester. And 5 to the 4th, that operational division cancels that operational multiplication. So it would be nice if we could make x minus 5 to the 4th become 5 to the 4th, and I think that's pretty easy by using the number 10. And hopefully that folks can see that that cancels, which gets us -1. Doesn't cancel, it gets us a 5 to the 4th divided by 5 to the 4th is actually the number 1, which then, you know, we don't have to show anything times 1. You get -1 plus 1, and that gets us -1 plus 1 gets us 0. A little sluggish here for starters. And we've been talking about negative numbers to a certain number of power, odd or even, and this is a negative number to an even, which makes it a positive, which obviously gives us another user-friendly number. Same answer. So this goes through the origin. It's actually in graphing form. And the graphing form for 4th degree polynomials is a lot of other stuff here, but in this particular case, that other stuff would be 0. So we don't have to get into that discussion. All right. So I've been talking about the ability to go up the ladder in this discipline requires your foundation to be strong. Many of you have that at the moment for this first year of study. You've been very successful, and other folks will have to cram the last week and a half to try to move up the ladder. So I'm just going to write this equation, 19 pi over 2, 18 pi over 2, 9 pi, but I'm going to do it in the context of where you'll use it in the future. And you'll use it in the future 1, 2, 3, 4, 5, 6, 7, 8, 9 for functions like this, which you haven't studied yet. A couple of you have, but most of you have not. But let's see if you recognize the equation of the line as I write it. All right, so let's make 1907. Let's give it a certain number. Let's go with 50. And let's go over here, 2000. Let's go from 50 to 10. No, that's not what I want. Let's go to 34. All right. And I'm just going to write this equation based on what I see, and see if you can spot where the equational line has an awful lot of meaning that you won't understand. Yeah, I don't know what I just said. 34 and 50 is 84, cut in half is 42. 42 is 8 units above. Okay, so I checked that. So I've got 42 plus 8. I'll make this a sine function. And here we go. Pi over 2 to 19 pi over 2 is 18 pi over 2. You should definitely call that 9 pi. Where am I? And that's going to happen in 93 years. And I'm going to make a 0 out of 1907. And I am going to put pi over 2 here. Huh. Wow, look at that. The ability to do that is going to allow you to study this function. And if you can't do this, you can't do this. Which means you can't go to another level of mathematics unless you can do this. All right, enough said. I guess we're solving an equation, so I know that x has to be greater than 0. That's the domain of this. Domain of logarithms, the parentheses has to be positive. Okay, I guess I asked how to solve this, so let's do the inverse operations, and I know the inverse operation of log 27-bit is 27 to the x. Okay, and these x's are different. This is actually a quantity. This is an exponent. Okay, so that requires some processing. So let's just do it. Subtract 6, 15, divide by 45, which gives us 1/3. 27 to the 1/3, because this is now an exponent. Okay, logarithms are exponents, and exponents equal exponents. I don't want to do 27 to the 21, that's for sure. Okay, so I recognize that. That's the same thing as the cube root of 27. And so that appears to be the number 3. So we'll put it in and see if it makes sense. Okay, what's the exponent that takes a 27? I need a cube root. A cube root is an exponent of 1/3. 1/3 of 45 is 15. 15 plus 6 is 21. I'm moving on. And I've been pushing verification. It was disappointing when I asked you to do verification on a homework. And then I made a video of that homework and explained in the video what verification was and how you do it. And quite a few students came into class and asking me, how do you do verification? Well, that was my verification of finding out who's looking at the videos and who isn't. All right, so I already knew anyway. All right, so what do we got for critical numbers? That's odd. There's a sign change. X cubed has a sign change, so I'm going to put a dash. X minus 4 is a linear function passing through 4, 0. There's a sign change from negative to positive for y values. When I plug in an x, I get a y. And so all these y values times these y values times these y values, I want to have less than or equal to 0. And y values are measured vertically, so I'm going to do it graphically after I do it as a sign chart. All right, so 4 dash negative 5, no sign change. X squared, right? The verticals are positive and then positive again. And positive numbers times positive, positive. All right, so what do we have here? We have true or false. Well, first off, these numbers make zeros, so they work. All right, you use any one of these numbers in that equation, you're going to get something equal to 0. So we have 3 numbers that get us 0, 0. So we have roots. Let's put a number bigger than 4 in. See if it's true or false. Excuse me. There we go. Hope I don't get the old allergies going. I like 1,000,000. I like the cube of 1,000,000. I like 1,000,000 to the first. I like 1,000,000 squared. And I think if you do that, you got 6. Oh, God almighty, you got 18 zeros. Oh, 19. And oh, no, I think I miscounted. Anyway, that's certainly false. Okay. Then this is going to be true, this is going to be false, and that's going to stay false. So my answer should be negative 5 works. So does 0 to infinity. Oh, geez, got to wake up here. Okay, and hopefully I've, oh, wait a minute, it's false over here. So I'm very sluggish here right now. Hopefully the brain will fire up. Okay, so that looks like it's the picture. And when you get to a calculus, if you ever get to a calculus, it's much better to graph these. And so if I put 1,000,000 in, this thing is going up. And so it would look like a nice linear cut. Polynomials increase, nice linear cut, a cubic root, a quadratic root, and in future classes, we'll take a microscope to that so that you can start to consider what I just said. And so I can see it equal, less than, and equal. And same answer, negative 5. union 0 to 4, and I don't know if I had a bracket there the last time. If I didn't, it should have been. All righty, let me move the charger. Got to charge up here, otherwise I'll run out of battery. I think we've been doing the absolute value problem since before midterm. So what do we got? What did I ask? Oh, I guess probably piecewise function. So, and that comes from the ability to see the graph, which from left to right is increasing and then decreasing. And it's important that you get that right. And the X value that's most important is 5. Okay, so it increases until X equals 5. And then if you put values like 6, 7, 8, 9, decreasing. So increasing 3, X minus 5 plus 4. And many of you thought 4 had something to do with the domain. It does not. That is a range value. And so X is on the left side of 5. Allow me to increase, positive multiplier. Other side, decrease. Okay, and that's what you've got to learn how to do. So you got to think about it. Let's see if I put this up just a little higher. All right, where's that helpful? Well, it's very helpful when you're solving equations. So we want this to equal -8. So I'm going to use the 2 branches. I'm going to use the increasing side. And I'm going to use the decreasing side. And I think everybody should be able to follow that. So if you're not, I think you're putting enough time in thinking about it. Okay, so let's just do this very quickly. Subtract 4, divide by 3, add 5. Let's put 1 in. 1 minus 5, -4. The absolute value of -4 is 4. 4 times -3 is -12 plus 4, -8. So yes, we have a height of -8 at X value of 1. Right? And it's 4 units from 1 to 5. So we can anticipate 9 getting me -8. I forgot the minus sign here. We can anticipate that. And let's just plug, well, I guess we can do it. -12, +4, notice the sign change. Add 5, there's your 9. Doesn't hurt to take your answers and divide by 2. 10 divided by 2 is 5. And I think we can see 5 is the critical number here. That's going to get a minimum, right? Measures, this absolute value measures distance from 5. How far is 5 from 5? 0 times anything gets us the Y value of the vertex, which is a range value. So the range of this function, all these Y values are less than or equal to 4. So one more time to hear that, one more rep. And you never know when that one more rep gives you an understanding of something that might have given you trouble earlier. All right, so now we're going to talk about when we're bigger than -8. So here's -8, and these are Y values. Answers to equations are Y values. So when am I bigger than -8? When numbers are like 0 and 10 and 20, when they're above. All right, so we already have a graph. You can answer it from the graph. Okay, you've got an X value of 5 here. You got an X value of 1 here. You got an X value of 9 here. And this is a height of -8. When am I above? Sure looks like those X values are between 1 and 9. But you could always simply do a sign chart, find the critical numbers, which we did over here, 1 and 9, and trial and error. I'm telling you, that's going to be true from looking at it graphically. But let's pick a number bigger than 9. I'll put 1,000,000 in here. -3 times 1,000,000. -3 million. Is that greater than -8. Let's see, here's the -8. I think -3 million is over here somewhere. And I think that's less than that. So. False. And it alternates. Okay. You've had the whole semester to look at that, so I hope you're getting it. Okay, so now what do we got here? We got to keep firing up this battery so it doesn't die on me. An equation, and x is only appearing once, so I'm not going to factor, I'm not going to graph, I'm just going to use inverse operations and hopefully appropriately. -25. Oh, this is next, all right? Because I got to do that in the parentheses first, so it's the last thing I'm going to do when I'm solving. So plus minus 5i. Okay, this is equal to plus minus the square root of -25. That's plus minus 5. I know that. And this symbol goes outside. So in this case, it's right there. I'm going to multiply that times 3. Okay, so that's gone. I'm going to multiply by 3, which is plus or minus 15i. And then I'm going to subtract 2. All righty. Let's hope I'm awake enough that I'm not making any careless errors. Well, let's conjugate this for your SATs. And if you become an electrical engineer, you work with some imaginary numbers. 2 plus 7i, 2 plus 7i. And we have Fact Brat, who is an electrical engineer. Congratulations, Mr. Kennedy. All right, 5 times 2, 10. 5, one of the hardest working kids I ever worked with. Very impressive. 5 times 2, 10. 5 times 7i, 35i. 3i times 2, 6i. 3i times 7i, this is where the mistakes are being made. 3 times I times 7 times I. Let's look at 2 times 3 times 4 times 5. Is that 6 times 20? 120, I believe it is. But let's move the 3 over in that direction to do 2 times 4 times 3 times 5, which is 8 times 15, which is also 120. I can move things around. I can move this I here and put it at the end. And let's do the multiplication. 3 times 7, 21. I times I squared. What does I squared do? It changes the sign in front of the coefficient in that setting. All right, so again, 3i times 7i, 21i squared. Oh, no middle terms. Minus 14i, positive 14i gets me 4 minus 49i squared. It's always going to get you positive times a negative. Well, not always, but it's always going to get you. The conjugate's always going to get you a minus I squared. So it's going to change that coefficient. All right, so 21i squared. Going to save a little bit of room here because I already talked about that. That becomes minus 21. All right, ready to do the problem now. 10 minus 21, like terms. 35 plus 6i, like terms. 4 plus 49, 53. Again, you'll see that on your SATs. Likely. All right, unplugging so I can move down the line. 23i to the 70th. It's great if you're writing I squared here 35 times, because that is the same as 23i to the 70th. It's great if you know that I squared is -1. 35 times, because that is the same as 23i to the 70th. It's great if you know that a negative multiplied times itself an odd number of times gets you a negative. So that is the same as 23i to the 70th. And that is negative 23, which is the same as 23i to the 70th. Okay, there's rapid fire five practice somewhere buried in those videos. Maybe I'll be able to find it, but if I don't, you go look for it. You get some practice. These are answers to completing the square problems. Let me do a completing the square. X squared plus 10x. Let's get something that's nice, plus 31. All right, that's going to get me answers like this when I do x plus 5 squared minus 25 plus 31 equals 0. Minus 25 plus 31 is minus 6 on this side. I'm going to do plus minus, which makes this thing plus minus the square root of 6. Addition of 5 makes minus 5. All right, and I needed an I here. Okay, so those types of answers come from that process. And if I'm able to get the answer, then it's got to be some neurons that can go boom, boom. All right, so first thing I do is I get back to the completing the square moment. I can make that a square by doing that. And by doing that, that becomes x squared minus 14x plus 49. That becomes 4i squared, which is negative 4. And therefore, I can bring negative 4 to this side, and I can get x squared minus 14x plus 53 equals 0. And that equation gets me those answers. So I will erase this and complete the square and get you those answers. And you play the video as many times as you need to till you can do it. X minus 7 squared minus 49 plus 53 equals 0. Many of you doing that correctly. X minus 7 squared equals minus 49 plus 3 is positive 4 equals negative 4. X minus 7 squared equals, sorry, I got to take the square root here. X minus 7 equals plus minus the square root of negative 4, which happens to be, move the negative sign outside, take the square root of 4 and call it an easier name, 2, and now I've got x equals 7 plus or minus 2i. I have plenty of time to learn that before next Wednesday. Plenty of time still. I don't suggest that's how you do it. If you ever take math again, I'd say stay with the material as it's presented, and you'll get a deeper understanding. But you can still pick that up pretty quickly and easily and within a week. All right, so this is the same thing as the cube root of 125 times x squared, y to the 9th, z to the 23, except for, I forgot to say times 2, except, let's put it in parentheses. Except for this part, this is the easier part, because all I got to do is divide the exponent by 3. And if it's a multiple of 3, it comes out evenly. And if it's not, it's got a remainder. So let me do that right now. Let's get rid of the easy part. X squared, not enough material. 3 goes into 9, 3 goes into 9, 3 times. 3 goes into 23, 7 times, with a remainder of 2. And that at least gets you half a point. So, and then if you can recognize a perfect cube root of 125 is 5, you take that out, leave what's left. I mean, what is 250? 250 is 2 times 5 cubed, right? 2 times 5 cubed. So I'm just taking 1 5 out. That's another way to look at it. And I guess I anticipated this problem, so I did write something last night, unless I just left it on the board here. So the cube root of 64 is 4, right? And 64 is 8 times 8. And 8 is 2 cubed. And 2 cubed times 2 cubed is 2 to the 6th. And 3 goes into 6 twice, and that's another way to see that the cube root of 64 is 4. But a cube root times a cube root, the cube root of 2 cubed is 2. And the cube root of, that's another 2. So a cube root times a cube root is a cube root. The same way a square root times a square root is a square root. And we've looked at the square root of 2 times the square root of 3. You shouldn't leave it like that. You should call it the square root of 6. And if you don't believe it, go to a calculator and start playing with some numbers. All right, so I guess we did that one. All right, yes, I can charge up. Let's do that. So who's doing this? Yep, I hear a little beep. Where am I now? 84. All right, so this is a little tricky. You haven't seen it. This is kind of like pizza in the oven or take the pizza out of the oven, one or the other. So 5, this is still an exponential. So this is a constant plus a b to the x. It's still in that form, except that we're subtracting. So I'll put a subtraction here. So I've got 5. I'm not quite sure what I asked you to do with this. I guess the range. Okay. So what do we got? We're going down 12. And then we're going down 24. Still behaves the same way as those other functions do. I mean, we should be able to see that 0 and 1 are the key numbers here. 2 to the 0 is 1. So 5 minus 12 is -7. So that's where this is right here, -7. I'm going down 12. Okay. So what we're looking at is we're looking at a function that basically looks like that. And if you're wondering how to get that, you have to do what I just did. You got to plug numbers in. You got to pick numbers and you have to take the time to analyze it. That takes work. That takes effort. You put the effort in, you make some gains, intellectual gains. If you do it repetitively, you don't put the effort in, you don't look at it, then you keep asking, I don't know how to do it. How do you do it? That's the game we're playing. So what's the range? All these y values appear to be where? Below 5. Okay. And you can actually, you can get it really close to 5. You can get, -5 point. Oh, I can generate that. But I cannot generate, whoops. I can generate, excuse me, 4.9999. I can generate that number. Right, but I cannot generate that number from this equation. And if you want to see why, pick some x values over here. What's the next value? -100. -100. Okay, well, what's 2 raised to the minus? That's 1 over 2 to the 100. Oh, God almighty. That's a really small number. That's like 0.01. I mean, that's, I think that's making this times 12, put a 2 over here and subtract that from 5. And I think you'll see that you're getting numbers in this vicinity. That's all I can tell you. All right, so what do you do with quadratics? You set them to 0. You got to get your variables on the same side of an equation. Why do we set it to 0? Because quadratics are all about length times width. And if we can put it in that form, we've got a quick and easy answer. And I can see that it's x minus 6 times x plus 2 equals 0. So I can see that I get zeros when I pick numbers like 6 and -2. That's why you learn it to write products. It's just one more tool for solving equations. And when you have unlike terms, all right, it's pretty hard to isolate x. Not in this case. I mean, I could have isolated x very quickly and easily that way too. I could have done x squared minus 4x. I could have left the 12 on this side. And then I could have done completing the square, x minus 2 squared minus 4 equals 12. And I could have solved from there, add 4, 16, take the square root plus minus 4, add the 2 over there, 2 plus 4, 6, 2 minus 4, -2. Not hard. But, I've been doing this for a long time and you haven't. So you got to give it some thought. All right. What do we got over here? Little SAT work. Yep. Those are the kinds of questions you might get. So let's do that. Okay, we can see what we're looking at. A times B. Use of parentheses needed.
3i plus 7 times 9i minus 5, and that's a times b. We've already done this, but let's do it again. 27i squared, which is the number negative 27, minus 15i plus 63i. Take 15 away from 63, 53, 5, 48. 48i minus 5 times 7 minus 35. Final answer, 25 and 35 is 50, 62. So minus 62 plus 48i. And getting the rep in class, seeing it again on a video, it's repetition. That's going to allow those neurons to connect. And if you put the work in, they will. And you'll do a little better on your SATs. B squared, well, B squared is 9i minus 5, so we're going to square it, taking the shortcut, 81i squared, which is negative 81. Erase that, make some room, start again. 81i squared, which is negative 81, want to say that right away. Doubling the product, that's minus 45i. Doubling that gets me minus 90i, and minus 5 squared is plus 25. 81 minus 25, 61 minus 5 is 56. So therefore, this is minus 56 when I put these two numbers together, minus 90i. That's how you do that problem. Okay, let's keep moving. I like this cart. Little things, such little things make so much joy. And I know that you can see the work on the board. All right, what did I ask? How to graph this side? Well, feel free to manipulate any equation. If you're more familiar with that form, seeing 4 or 5, we'll call that point A. Changing by 3, changing by 2, we'll call that point B. Looks like I'm increasing. So this is a function that's going up. And you can do over 4, let's call that 4, 5, let's call that point A. And then over 3 more, which would be about there, up 3, I don't care, anything like this. But you do need to somehow label the points. Communicate that to me. This is called point slope form. So 2/3 is the over 3 up 2 process. And you're supposed to see a 5 on this side makes a 0 and a 4 on that side makes a 0. I personally think that the discipline should move in that direction because so many functions can be written from that form. And that should be studied. All right, so that's that problem worth 2 points on the final. All right, minus 3x squared. Cup shape down. On the decreasing side, I have -5. 0, -5. You don't have to do it that way. If this is, I've explained a number of times why that's true. I'm not going to again. Let's see, you can look at the videos for that. So I now know that I have a negative x value because I'm to the left of 0 for that x value. So I know it's negative. So all I do is divide 3 into 12, which is 6, cut it in half. And so I get that. But you take more time with it, minus 2d over 2a, minus b is positive 12 over 2, -6. And I made a mistake. 3 into 12 is 4, divided by 2 is 2. So it's a good thing I did that just then, because I'm talking, not thinking. All right. So -2, but I knew it was negative. And I would have found the error anyway, because if I have a number like 10, the next number has to be -20. Okay, so let's say I did put -3 in there, then that's 36. -3 squared, -27. I'd go, oh, I made a mistake. And so now I'll put -2 in, which is 24, which means I can cut it in half and subtract 5. And that's 7. You take more time with it. -2 squared is 4. That's -12. That's plus 24. minus 5. And you notice when you add those up, you do get 12, which is half of that. So if you're seeing those numbers, quick way to do that. All right, and then you're done. Domain all reals, range, y values less than or equal to 7. Okay, 2 points. That's worth 2 points on the next test. It's been worth 2 points on every test. All right, we got an absolute value. This is one of those problems that everybody in the room should be able to do. A positive absolute value is a V shape. I don't know what to say. Should be no blanks. There should be no blanks on a test. A negative absolute value is a V shape down. Okay, enough said. What makes a 0? Absolute value is distance. And the smallest distance you can travel, and this is a minimum. What's the minimum? The minimum is 9. You cannot get a number out of this function that is smaller than that, because distances are positive, and 4 times a positive, things are going up from positive 9. All right, so when do I get a 0? When x is 3. And so this is really measuring change. This is the graph of x minus 3 passing through 3, 0 with an over 1 up 1 slope. When I slap an absolute value on this, all of these negative y values become positive. And what am I doing? I'm multiplying every one of these y values by 4. So they're 4 times going up 4 times faster. And then I'm raising the whole kit and caboodle up 9 units. And that's why people teach transformations. And you might as well at least hear that. I'm not a transformation fan. I'm much more about understanding the numerics. Plugging in a 0 to any function will get you your y-intercept. So therefore, 3 times, I hope that's true. Maybe there's a situation where it's not. Somebody can write to me and tell me, hey, that's not true. So 0 gets me 4 times the absolute value of negative 3 plus 9. Not hard to do. 12 plus 9, 21. How do you get from 21 to 9? You go down 12. 0 to 3, divide by 3. So this side is going down at a 4-to-1 ratio. This side is going up. And that refers to a problem we did earlier. Piecewise functions. All right, so that's that graph. 2 points. Shape, half a point. Vertex. Got to be worth at least a half a point. Another half a point for the y-intercept. But 2 points makes it easier to correct. So if you get 2 out of those 3 things, then you get a point. If you get all 3, you know, maybe you get the full credit. That's probably how I'll grade it. All right, so people are still not graphing this from the perspective given. I haven't seen anybody graph. Maybe one person did. I'll have to go back and check. But folks are generally not seeing 2x times 3x, 6x squared. So there's your shape. What are the critical numbers? 4 and negative 2. They get you zeros. And you've been working with that, but you're not employing it here in this context. All right, so what's that tell me? It tells me between negative 2 and 4, 2 divided by 2 is 1. I can put a 1 in here and get minus 6 times 9, minus 54. There was no reason to multiply this out. None. So, a couple of points. I mean, if you multiply it out and you get the right graph, I guess I got to give you credit for it, but it's not what I'm testing you on. So if you want to impress me, show me that you understand what's in the video here. Okay, it's moving right along. I don't think I need to plug in now. I got enough juice. Oh, look at this. Friendly numbers, friendly numbers. Why did I write that? I did this last night. I guess these are years that are going to come out, right? Oh yeah, now I remember. So I really have 2001 plus 50 times some number over here. And it would be nice if these numbers were, yeah, minus 2, minus 1, 0, 1, 2, 3, so on and so forth. Because I can take 100 away from 2001. I guess I did that over here. All right, so then the question is, how do I make these numbers with this expression? Well, that's what's up above here.
That's how you make those numbers. Okay, and any of those, all you need is 2. Okay, so this graph has to be positive, so numbers have to be bigger than -9. So this is about, I've only given you the inverse of growth. And that's a base there, that's a growing base. If it had been 1/3, would have gone in the other direction, but that'll come in the next level of study. We'll highlight that more. And I know 1/9 is -2, right? So I could set x plus 9 over 8 to -2. It's not hard. I don't think I want to do that. I think I want to set it to 0. I want to get this logarithm base 3 to equal to 0, which means that I really need to set this equal to 1. So there are 3 things that I think are the easiest for this situation. And we used to make a mantra out of it, say it a lot, but this is the first year of study. So you want that to equal 0. You want the parentheses of the logarithm to equal 1. And you want the parentheses of the logarithm to equal the base. And the base in this case is 3. Okay. And so those are the numbers that I would use here. And I think I highlighted, well, let's just do it out. So -8. Did I say, oh, I miscopied this. Okay, I was going to say, that was a 9, that was an 8. You can tell I'm getting tired. That's a 9, that's an 8. And I've done too much of the video to start this again, so we're just going to continue on. Get rid of that carelessness. Okay, so when does this equal 0? That's the asymptote. Okay, so you're trying to process a logarithm. You set the argument to 0, and you get your domain restriction and asymptotic behavior. Because the closer I get to -9, the more my values are decreasing with negative exponents. The bigger the negative, okay, and numbers like 1/9 and 1/3 and 1/27 and so on and so forth, they're not changing much. So my x values aren't changing much, but my y's are. All right, so that takes care of the asymptote. This is going to get the easiest point. If I make this a 1, what do you put on top of any base to get a 1? 0. 0 times 50 is 0. So that's going to get me this. So let's solve that equation. 8 times 1 is 8. Minus 9, -1. And if you look at how far -9 is to -1, you'll see that it's 8 units of change. All right, so there are deeper ways of understanding these problems, and that's not going to stop. All right, but you got to get the foundation of it first before you can start looking at it more critically. All right, and if that's 8 units, I got a feeling the next one's going to be 24. 3 times that. Because logarithms are the inverse of exponentials, which means you're changing the x's and the y's. You still got a little bit of an exponential look, but it's x equals a function of y. That produces the exponential. Okay, so that takes care of 2001. And then we want this to be 8 times 3. Oh, yes, 24 minus 9. 24 minus 9, I believe, is 15. Yes, 15 should get us 2051. Let's find out if 15 does. 15 plus 9 over 8. Let's do that math. 15 plus 9, 24. 24 divided by 8, 3. Oh, what do you put on top of a 3 to get a 3? The exponent of 1. 50 plus 2001, 2051. Okay. And if you want to see some of these values, then you're going to have to set them equal to these kinds of numbers, the whole equation. All right. I got a little tired there. I'm not sure I said what I wanted to just say 10 seconds ago, but let's keep going. All right, so what are the nice square roots? Square root of 4, square root of 9, square root of 16. So wouldn't it be nice if x plus 7 became these numbers? I don't think you need a calculator. All right, so square roots. Side lengths of a square. I can make that square smaller and smaller and smaller. I can make it bigger and bigger. Whoa, a little bit of change gets a whole lot of new area. Oh, wow, that's a layering process. That's calculus. All right, so what's the smallest square you can have? 0, 1. That's the key. Okay, that gets you a minimum. And a negative times a minimum is a maximum. So this is the square root function that's going down. And you can pick any of these numbers you want, but you got to start with that one. -7. All right, because the domain of this is x has to be greater than or equal to -7. Otherwise, you get negative roots and they're not going to show up on the Cartesian coordinate system. So what do you get if you put -7 in? Cancellation, you get the smallest square root, which is 0. So we get -14. And any one of these is, I like this one. I like 25. That was a good age. So it's 25 again. All right, so x plus 7 equals 25. So I'm going to put an 18 in. And my brain's going to work. 18 plus 7, 25, square root of 25, 5. Minus 2 times 5, minus 10, minus 14, minus 24. And yes, that is smaller than that. All right, so that's how you look at that problem. Alrighty. Now, some of you are graphing the exponentials with ease, which means that you should be, with repetition, just doing a little faster each time. And I'm getting very tired. So I'm going to do this problem and this one, just going to do them real quick. So what do I see? Asymptotal y equals 3. I see exponential decay. So I want to get a jump of 24. Then I want 1/3 of that, which is 8. That looks pretty good. So I can nail these 2 points pretty quickly and easily. Let's make that look a little better. All right, so what am I going to pick? I'm going to pick 11. So 11, and then I'm going to pick 7 greater, 18. That 24 should get me 27. Jump of 3 and 24 should get me 27. And 18 should get me 11. Let's just check 18 and 11 real quick. 18 minus 11, 7 divided by 7, 1. So that's 1/3 of 24, jump of 8, good enough, done. All right, next one. There's tons of problems like that on the YouTube channel. So if you want to graph exponentials and get it right, 2 points on the next test, that's up to you. All right, so what do I have? I have 4 possibilities. Y equals E. I got the chicken in the oven. Let's make it a pizza. I've got the coming out of the oven. I've got exponential growth, and I got exponential decay, because I'm not telling you whether A is positive or negative, and I'm not telling you whether B is, between 0 and 1 or greater than 1. I mean, cutting something in half means the distance from E is being cut in half, or I guess that's cut in half, or it's getting doubled. All right, so what do we have? Ah, darn, do I really want to do this? I've got A plus E, and I've got A, B plus E. I can generate those very easily all over the place, every single one of these. So I'm getting tired here. So let's just say that I wanted A plus E. So let's get some numbers here, and I'll do this one. So let's look at 10 1/2 to the x minus 3 over 4 plus 5. There, that's not too bad. All right, so I'm suggesting that I can get 10 plus 5, 15, A plus E, 15, pretty easily by making this a 0, which is 3. Okay, so 3 minus 3, 0, 1/2 to the 0 is 1. So I get a jump of 10 plus 5, A plus E. Now I can get AB plus E, which is 10 times 1/2 plus 5, by making this thing equal 1. Okay, so when does this equal 1? 7. Okay, so anything to the 1 is itself, and I get 10 times 1/2 plus 5, which is 10. And I could do that on every single one of these curves. I could double that,
right? And instead of decreasing, I have increasing. And if I had a minus sign in front of it, I'm gonna get one of these graphs. We did it earlier, all right? And that's why it was a challenge question, but I don't know if you would have thought of 4 possible graphs. All right, good to think about. Okay. Out of breath. All right, so that's 72 through 93. The worksheet's in your hands. I have one more worksheet that you can use as a study guide. I'll hand that out after your test, or maybe I'll hand it out Wednesday night. And then we've got a help session next week early on Monday, a reading day. You can come in for some help. And I think our test is a week from this Wednesday. Last test. The last of 20 finals. All right. See you tomorrow.